Here in section 2.1, we want to review a few concepts that we learned in college algebra. The first is a definition of a function. A function is a rule that assigns to each element in the domain one and only one element in the range. In other words, for every value that goes into a function, there's only going to be one answer that comes out of that function. The values that go into the function, those are the x values. We call the set of all of the x values that go into the function, we call that the domain of the function. The range is the set of all y values that come out of the function. So the first thing we want to look at specifically is evaluating a function. So we know from college algebra that a function is typically given as an equation. So here we have the function g. G of x is equal to negative 3x squared plus x minus 4. And we would like to evaluate that function at three different values. The first says to find g of negative 1. So we know what that means. That means we want to go to equation g. Everywhere that we see an x, we're going to replace that with a negative 1. So my first suggestion is that you write out the function. So write out that equation, but in place of x, put parentheses. So everywhere that I have an x, first I'm going to just put parentheses. Now inside of those parentheses, I am going to put in a negative 1. So whatever's in the parentheses on the left, we're going to put that into all of the parentheses that are on the right side of that equal sign. So I'm going to drop into the equation a negative 1 in place of x. And now we want to simplify this. So we're going to use order of operations, or PEMDAS, to simplify. Okay, so the P means we're going to do what's in the parentheses first. There's nothing to do within the parentheses because all we have inside of the parentheses is a negative 1. The next thing we look at is exponents. We do have an exponent of 2 on that negative 1. So let's square negative 1. Negative 1 squared, so negative 1 squared is a positive 1. So that gives me negative 3 times a positive 1 plus a negative 1 minus 4. The next thing we do is any multiplication or division as they appear from left to right. Okay, we do have some multiplication. Negative 3 times a positive 1, that gives me a negative 3. Right, the last thing that we do is any addition or subtraction as it appears from left to right. So we have negative 3 plus a negative 1. That gives me a negative 4. Okay, then we'll bring down the negative 4 that's on the right-hand side. And now we have negative 4 minus 4. That's our last addition or subtraction. And that gives me a negative 8. So our final answer here is that g of negative 1 equals a negative 8. So negative 8 is our final answer there. All right, our next problem says g of a. Okay, what does that mean? Well, we're putting a into our function g in place of every x. So once again, I am going to write out our function, but in place of x, I'm going to put in parentheses. So the first step of evaluating a function is always the same. Write down the entire function, but replacing the variable x with parentheses. Now we are going to take what's in the parentheses on the left side of our equal sign, and we are going to drop that into all of the parentheses on the right side of that equal sign. So I'm going to put in a. And once again, we are going to simplify using PEMDAS. So the first thing that we have is squaring. So that's a squared. And a squared, there's really not much we can do there. That's just going to be written as a squared. So we did the exponents, multiplication and division. There's also not much that can be done here in way of multiplication because negative 3 times a squared is just negative 3a squared. So not a lot of simplification that can be done here. When it comes to the addition and subtraction, we have to look for like terms. In this case, in order to combine like terms, each term would have to have the same variable and the same exponent on that variable in order to be combined. Since this term has a squared and this term has just a, these are not like terms. Since the last term doesn't have an a in it at all, then it is also not a like term to any of the other terms within the function. So our final answer here is just going to be negative 3a squared plus a minus 4. That is as simplified as it can possibly be. So that is our final answer. The last of these three evaluations is the most interesting. The first step, though, for evaluating is the same as it was before. To find g of a plus h, I am going to first write out the function g, replacing all of the x's with parentheses. So that's negative 3 parentheses squared plus parentheses minus 4. You'll notice that I gave myself a little bit of room there, and that's because I am going to put in a plus h into all of the parentheses on the right hand side of that equal sign. Now once again we are going to simplify using PEMDAS. So we have already said that parentheses would be technically the first step of order of operations in simplifying. Can I add a plus h within the parentheses? And once again, that does not fall under the category of like terms, because in order to have like terms, in order to be able to combine them, you have to have the same exact variable and the same exponents on that variable. But here we have two different variables, a and h, so those are not like terms, and so they cannot be combined within the parentheses. Okay, so we've checked that. Do we have exponents? Yes, we do. So we have a plus h in parentheses quantity squared. So we actually have something to do in that step. Now, here's something that you want to be careful about. When you have two terms inside of the parentheses, so two terms and it's being squared, then you actually have to write that out as that binomial times itself. So if you have a plus h squared, that's actually a plus h times itself, a plus h. So be really careful here when you are squaring a binomial or squaring something in the parentheses that has two terms. You have to actually write that out twice, and then we are going to FOIL. Okay, so I'm going to do that first step. A plus h squared is a plus h times itself. Okay, so that's the first thing you do when you want to square something that has two terms inside of the parentheses. And now I am going to FOIL that. So we're going to FOIL. Foiling is multiplication of two binomials. Alright, so first times the first, a times a, that gives me a squared. Outer times the outer, so that's a times h, so that's ah. Inner times the inner, that's a times h again, or h times a, doesn't matter. We'll just write it as ah. And last times the last, h times h, so that gives me h squared. Alright, so now we have FOILed, or done the multiplication for those two binomials. Now, are there any like terms that can be combined there? So I would say yes, ah and ah, those two terms have exactly the same variables and the same exponents on those variables. So those can actually be combined as like terms. So we have inside the parentheses a squared plus 2ah plus h squared. Alright, so we've taken care of our exponent, and now let's move on to multiplication and division as they appear from left to right. So this negative 3 that's in front of the parentheses can be distributed to all of the terms that are inside. So that would be negative 3 times a squared, so that's negative 3a squared, Negative 3 times a positive 2AH would be a negative 6AH. And then a negative 3 times a positive H squared would leave us with a negative 3H squared. Okay, that's the end of that multiplication because the negative 3 would only be distributed to what's directly beside it in the first parentheses. Okay. If you want to, you can imagine that what's in front of that second parentheses is a positive 1. And when you distribute a positive 1, nothing changes. So 1 times A is A, 1 times H is H, minus 4. Now when we look at all of these terms, there are no like terms left. We have A squared, but there's no other term that has an A squared. We have an AH, there's no other term that contains both an A and an H together. We have an H squared, but there's no other term that has H squared. This term just has an A in it. There's no other term that has just an A. This term has just an H in it, and there's no other term that has just an H in it. And this last term, negative 4, doesn't have any variables in it at all. So there is no adding or subtracting that can be done. There are no like terms, so this is our final answer. The next topic that I want to review is piecewise defined functions. Piecewise defined functions are functions that are defined by different rules over parts of the domain. So here we have the function f of x. So we only have one function, but it's defined in two pieces. So there are two equations that represent this one function f. The top rule or equation is x squared minus 1, and the bottom rule or equation is the square root of x. We are only allowed to use these equations under certain conditions, and those certain conditions are given after the word if. So we're only allowed to use that top equation if x is less than or equal to 0. So we call these domain restrictions. So there are restrictions placed on x or the domain that tell me when I am allowed to use that particular equation or that particular rule. So the bottom equation, square root of x, is only allowed to be used if x is strictly greater than 0. If x is greater than 0, then that tells me to use the bottom equation for that x value. So for part A, we have f of negative 2. So we have to decide, are we going to use the top equation or are we going to use the bottom equation? Well, that all depends on the x value that is given inside of the parentheses next to that function name f. So here we have a negative 2. Does negative 2 fit into the top requirement or the bottom requirement for those restricted domains? So in other words, if this is my x value, negative 2, is that x value of negative 2 less than or equal to 0, or is that x value negative 2 greater than 0? Well, negative 2 is less than or equal to 0, so this is not true. Negative 2 is not greater than 0. Since the top statement comes back true, then that tells me that I want to use that top equation for this x value. So I'm going to write equals, and I'm going to use that top equation, replacing x with parentheses. And then I'm going to drop into the parentheses a negative 2. So we have to first look at the x value and decide which restricted domain does it fit into. So if I put that x value in place of x, which one comes back true? And the condition that comes back true, that lines up with the equation that I want to use for that function. All right, so negative 2 squared, that's a positive 4. 4 minus 1, that gives me a positive 3. So f of negative 2 is a positive 3. Notice that for every x value that goes into this function, only one answer comes out for the y value. And that's the definition of a function. For every one x, we only get out one y at a time. Now let's look at part B. For part B, we're asked to find f of positive 2. So positive 2 is the x value that I'm asked to use for this function. So I'm going to take that positive 2 and I'm going to test it in the restrictions given at the end of that piecewise function. So I'm going to replace x with 2. So I have x less than or equal to 0. I'm going to replace that with 2 less than or equal to 0. Or, for that bottom restriction, that's a positive 2 greater than 0. So which one of those inequalities is true? Is 2 less than or equal to 0, or is 2 greater than 0? So this is not true. 2 is not less than or equal to 0, but 2 is greater than 0. Since this statement comes back true, then our x value fits within that bottom restricted domain. That means I am going to use the equation that's right in front of it. So to evaluate this function f of 2, I am going to use the equation square root of x. Alright, so I'm going to write out my equation, square root of x, replacing x with parentheses, and I'm going to drop into those parentheses a positive 2. Okay, so there's not much that we can do there. 2 is not a perfect square, so I'm going to leave my answer as just the square root of 2. Alright, so that's what we would call an exact answer. If I would like to find an approximation, I can pull out my calculator and put in the square root of 2. And so the approximation for that would be about 1.4 when I round to the nearest 1 decimal place. So when you're doing your homework, be aware that the program is probably going to prefer the exact value, so you leave it with the square root on it. If it asks for an approximation, then you can put that into your calculator to find that approximation. Alright, part C is asking us to find f of 0. So we want to evaluate this function at 0. That's our x value. So I'm going to take that x value and I'm going to put that in place of x in the restrictions that I have at the end of that piecewise function. Alright, so everywhere I see an x, I'm going to put a 0. So do we have 0 is less than or equal to 0, or 0 is greater than 0? So which one of those inequalities comes back true? Well, 0 cannot be strictly greater than itself. So 0 is not greater than 0, and that's a false statement. But 0 can be less than or equal to 0. So the or equal to part tells me that this statement is actually going to come back true. So since the top inequality comes back true when I replace x with 0, then we are going to use the equation that is in front of that true inequality. Alright, so I'm going to write out my equation, x squared minus 1, replacing x with parentheses. And I'm going to drop the 0 into that parentheses. 0 squared is 0. 0 minus 1 gives us a final answer of negative 1. Alright, so for piecewise defined functions, you have to take the x value, test it in both of the inequalities. Whichever inequality comes back true, then you use the equation in front of that true inequality to evaluate the function. For example 3, we have another piecewise defined function. This function is named g. So we have g of x is equal to, we have two equations here that represents this one function. We have negative 1/2 times x plus 9. And we also have the square root of x minus 3. Now the top equation can only be used if the x values that I'm putting into the function are less than 3. The bottom equation can only be used if the x values that I'm putting into this function g are greater than or equal to 3. So these represent our domain restrictions that tell me when I'm allowed to use those equations in front of them. So let's look at our first part. G of negative 3. Does negative 3 fit into the top inequality or to the bottom inequality? So let's replace x with negative 3 and see what happens. So negative 3 less than positive 3, or negative 3 greater than or equal to positive 3. So which one of those statements is true? Well, negative 3 is definitely less than positive 3. That's a true statement. Negative 3 is not greater than positive 3. So that's a false statement. So what that tells me is that the x value of negative 3 makes that top inequality true, So I have to use that top equation when doing the evaluation. Right, so I'm going to copy down that top equation, replacing x with parentheses. Negative 1/2 times x plus 9. So now I'm going to put negative 3 into the parentheses. Now when you simplify this, you can do PEMDAS and do that by hand, or you can also pull out a calculator. So I'm going to show you this time how to do this all at one time in a calculator, and I'm going to use desmos.com. So desmos.com is a free online graphing calculator that you can use on all of your exams and all of your homework if you wish. You're allowed to use any calculator that you want to, but this is a really nice one. Alright, so we want to type into our calculator negative 1/2. I'm going to multiply that by negative 3. I'm going to add 9. So that gives me 10.5. So that's the decimal version of my answer. What's really nice about Desmos is that if I would like the fraction version of that answer, I can click on this little circle with that little fraction. And it tells me 21/2. So it doesn't matter which answer we give, but you have both of those options. So I'm going to write my answer as 10.5. Okay, once again, we're talking about a function g here. One x value in should only give me one y value out at a time. So if I get two answers out for this function, I know that I did something wrong. Alright, now let's look at part B. We're asked to find g of 0. So the x value that I'm asked to use for this function is 0. So I want to know, does 0 fit into the top inequality to make it true, or the bottom inequality to make it true? So everywhere I see an x, I'm going to replace that with a 0 in those inequalities. Right. 0 is less than 3, so that is a true statement. 0 is not greater than or equal to 3. That's a false statement. So once again, since the top inequality comes back true, that means that I'm using that top equation to calculate g of 0. So we're going to do negative 1/2 times x plus 9. I'm going to put the 0 into those parentheses. Now I don't really need a calculator for this one. Negative 1/2 times 0 is 0. 0 plus 9 is 9. So our final answer for part B is a positive 9. Alright, for part C, we're asked to find g of 3. I want you to notice something here. For this x value, we're given a positive 3, and positive 3 is what's used in our domain restrictions. So if the x value that you're putting into the piecewise defined function matches the number that is used in the inequalities, then what you're looking for is the inequality that contains the equal sign, so that bottom half of that equal sign. So our bottom inequality that contains the equals should come back true. So let's just verify that. If I go into the inequalities and I replace that x value with a positive 3, we get 3 less than 3. And then for that bottom inequality, I would get 3 greater than or equal to 3. 3 is not less than itself. That's a false statement. But 3 is greater than or equal to that positive 3. The key here is the option that we have at the bottom, that or equal to, because 3 is definitely equal to itself. So that statement is true. So if that inequality comes back true, then we know that we're going to use the bottom equation to calculate g of 3. Okay, so I'm going to write the square root of x minus 3, replacing x with those parentheses. Now I'm going to drop that 3 into the parentheses, and I'm going to simplify. 3 minus 3, that's 0. We always simplify everything underneath the square root first. So we have now the square root of 0. The square root of 0 is 0. 0. You're welcome to use your calculator for that if you wish. For this next page in your notes, there's really nothing to do here. It's more of a reference page, just to remind you of the basic shapes that you learned in college algebra. So if you see x squared in the equation or the function, then you remember that that is going to give you the shape of a graph of a parabola. Okay, so it tells you clues to look for in the equation, shape to expect when you actually graph it, and a reminder of what those equations or functions are going to look like. So we're just going to use this as more of a reference page, so you can refer back to it if you need a little refresher.